Imagine you're driving in the city during rush hour. You stop at a traffic signal and, to your dismay, see many cars ahead. The light changes and the car at the front goes first, followed by each car in order. This sequence of movement is like a queue data structure in Java. In this video, you'll get an idea of what a queue data structure is, specifically a standard queue. You'll see a breakdown of how a queue works using the first in, first out, or FIFO rule, and compare it to a real-world example to help you understand. So, what is a queue exactly? A queue is a linear data structure that stores elements in an ordered sequence. Elements are added at the back and removed from the front. A queue follows a first in, first out principle that defines its operation, making it ideal for scheduling processes or handling asynchronous data. To visualize the FIFO principle, think about how cars line up at the signal. The first car to arrive is the first one to leave. In the same way, the first element added to a queue is the first to be removed. A queue supports two primary operations, enqueue and dequeue. Let's quickly look at each. In a queue, you use the enqueue operation to add an element at the end, like a car joining the back of the line. Dequeue removes the first element from the front, just like the car at the front of the signal drives away when the light turns green. In a queue data structure, the first element added, or enqueued, is the first one removed, or dequeued. Let's see this visually. Imagine a queue of numbers starting with 2 at the front and ending with 6 at the rear. To dequeue, you would remove the front element, which in this case is 2. 3 now moves to the front of the queue. To enqueue, you would add a new element, 8, to the rear of the queue. You may have noticed the terms front reference and rear reference in the image. These play important roles. The front reference indicates the position of the first element in line, in other words, the next car to leave the traffic. This indicates the element that will be dequeued, removed, next. The rear reference represents the position where the next element joins, in other words, where a car joins the traffic line at the back. In the queue, this is where the next element will be enqueued or added. The front and rear positions change as more cars enter or exit the traffic line. Similarly, when elements are added or removed from a queue, the front and rear references adjust to show their new positions. Keep in mind that a queue can't accept more elements once it reaches its defined capacity. This constraint depends on the queue's implementation, whether it's backed by a fixed-sized array or a dynamically expanding structure, like a linked list. Now let's see how this works in Java. Let's first focus on the enqueue operation. When a new car arrives at a traffic signal, it joins the back of the line, just like the enqueue operation, where new elements are added at the rear and processed in order of arrival. In the code, the first step is to check if the queue is full using isFull. If it is, the process stops, and a message is displayed. Queue is full, cannot enqueue, in this case. If the queue isn't full, the rear index is incremented, and the new item is added to this updated rear position. Finally, the queue size is increased by 1 to reflect the new addition. Simple and efficient. Now let's focus on the dequeue operation. Here, the first element is removed from the front, like the first car to leave when the light is green. This process is critical because it keeps things running smoothly. Without removing the first car, no one else can move forward. If the car at the front stayed put, blocking everyone behind it, traffic would become chaotic. So, when the traffic signal light turns green, the car at the front of the line moves first, making room for the cars behind it to move up. This is how the dequeue operation works in a queue. The element at the front of the queue is the first one to be removed. In the code, first check if the queue is empty using isEmpty. If the queue is empty, a message is printed and -1 is returned. If not, the item at the front of the queue is stored and the front index is incremented to reflect the removal. The size is reduced by 1 and the dequeued item is returned. Great. Now you know how to use the enqueue and dequeue operations in your IDE. Now imagine you're in a long line of cars at a traffic signal, wondering how long the wait will be. You might peek ahead to see which car is at the front, but without moving or changing their positions, just a quick check to estimate when the light might change for you. In Java, you can use the peek operation to do something similar. Check the first element without altering the queue. This operation is useful in task scheduling to check the next task or data without modifying the queue or disrupting future operations. The code first checks if the queue is empty using isEmpty. If it is, it prints a message and returns -1 to show that there's nothing to peek at. If the queue isn't empty, it simply returns the item at the front without removing it or modifying the queue. Handy. In this video, you explored the concept of a queue as a linear data structure that follows the first in, first out principle. You observed how it can be compared to cars at the traffic signal, where the first car to arrive is the first to leave, and new cars join at the back of the line. Just like managing traffic flow, queues play a crucial role in many real-world scenarios, from task scheduling to resource management and computing. Keep practicing, and you'll see how valuable queues can be in solving problems.